Yes, students, continuation. Next question, students. 4 point masses are kept 4 corners of square as shown in diagram. Taking the origin to be 1 kg, okay. Then y coordinate of center of mass. Important, students. Now 1 kg origin given. So this position 0, 0. L distance is nothing but here L, 0. 3 kg particle L, L. And this 2 kg particle 0, L. Now YCM asking students. Position of center of mass along y direction, YCM equal to M1 Y1 1 into 0 plus M2 Y2 2 into 0 plus M3 Y3 like this, students. 3 into L plus M4 L4 2 into L by M1 plus M2 plus M3 plus M4. Total mass here 8 kg. Normal only, students. 3L plus 2L is 5L. 5L by 8. So it is given option 3, student. Easy only. What is XCM is nothing but M1 X1 plus M2 X2 plus M3 X3 plus M4 X4 by M1 plus M2 plus M3 plus M4. Formula based question, easy. Next question, students. A vector given, B vector given. What is vector product? Important, students. Vector product A bar cross B bar. Vector product how easily calculate? You know very well. I, J, K. First vector components 1, 1, 1. Second vector 1, 2, 1. If you want I component is determinant. Cross product. So I into 1 minus 2 minus J second minus J into 1 into 1 minus 1 into 1 plus K into 2 minus 1. So that means here 1 minus 2 minus I 0 plus K minus I plus K, it is given first option. Cross product also fastly you can easily calculate. Next, a particle of mass is 2 kg moving with velocity 10 meter per second along straight line x equal to 2 meters. Like this, students, important say here. X equal to 2 straight, x equal to 2 meters, yes. Straight line moving with velocity v is given, okay. Particle moving with velocity v, okay, students. Magnitude of angular momentum of particle about origin. Angular momentum L equal to R cross P. R cross MV. Correct only, no? R cross MV. So now MV perpendicular component. Perpendicular component about origin is 2 meters only, students. So L equal to R MV. All values given. R is perpendicular component 2 only. 2 into mass is given 2 kg, yes. Velocity also given 10 meter per second. Easy only, students. So 2 into 2 4, 4 into 10 40. So 40 kg meter square per second. First option given. Okay. So this is only perpendicular component, students. This is not perpendicular, this is not perpendicular, whatever. Perpendicular component is only this 2 meters. Okay. Yes. Which of the following given relation correct? It is easy only, students. Relation between linear velocity, angular velocity, vector notation v equal to omega cross r bar, students. This is correct option. So here r cross omega also given, wrong, students. V equal to omega cross r. Vector notation. Next, the analog of mass in rotational motion. Very important. Mass in rotational motion. Analogous mass of rotational motion is moment of inertia. So analog of force is nothing but torque. Analog of linear momentum is nothing but angular momentum. So these are very important direct questions. It is moment of inertia, first option. Next, angular momentum of a body is given, yes. Magnitude of torque. Differentiation. Torque tau equal to dl by dt. T equal to 1 second. So torque tau equal to differentiation of L. 3t square 6t plus 2. t equal to 1 second only, torque tau equal to 6 into 1 plus 2. That means 8 Newton meter given second option. Magnitude of torque dl by dt. Newton's second law in rotational motion. Next, assertion reason, students. Moment of inertia of two identical spheres having same masses, one solid other hollow, are equal. Yes, students, moment of inertia depends on masses and their relative positions from axis of rotation. Masses same is nothing but moment of inertia equal, but distances, solid sphere is solid sphere, other is hollow sphere is given. So solid sphere moment of inertia 2 by 5 mr square, hollow sphere is nothing but 2 by 3 mr square. Unequal, correct only, students, this is correct, unequal. Next, moment of inertia is minimum when axis of rotation passes through center of mass. Very important, parallel axis theorem, students. What is moment of inertia? For example, ring consider. What is moment of inertia passing through center is mr square. What is moment of inertia about any tangential perpendicular means mr square I equal to ICM plus mr square. R is distance from axis of rotation. Now here ICM plus mr square means because of this plus it is more only. Wherever you consider moment of inertia more only center is minimum. So moment of inertia is minimum when axis of rotation passes through its center. Exactly correct, students. So both statements is correct, but no relation, students. Both assertion and reason is correct only, but reason is not correct explanation of assertion. Second option is correct. Clear? Moment of inertia, mass is same only, but solid and hollow is nothing but these are unequal. Yes. Next, force is given, position vector r is given, the magnitude of vector product to scalar product, vector product to scalar product, r cross f vector product to r dot f. Yes, cross product just for easy here, students. Force F equal to given 3I plus 2J minus 2K is given, or position vector multiplied with 3, students, for understanding. So now here position vector multiplied with 3, you will get 3I. So here plus 3J. So here it is multiplied with 3 is nothing but minus 2K. Same only, no, students. It is multiplied with 3 is nothing but you will get same like force only. So cross product I cross I is nothing but 0, j cross j is 0 is nothing but this value you will get 0 only, students. So this value 0 is nothing but 0 by something, 0 only. Okay. So cross product law like normal what I explained above also, you can calculate r cross f, you will get 0 only, students. Clear? It is easy only. Next, linear velocity of center of mass of hollow sphere of radius is r, rotating with angular velocity omega about fixed axis, passing through its center about its own axis, linear velocity asking. So it is revolving with angular velocity omega. What is linear velocity about own axis, students? V equal to r omega, r 0 only. So what is linear velocity about its own axis is nothing but 0, students. It is also easy. Okay, linear velocity 0 about its own axis. Next, uniform rod of mass is m and length is l is pivoted one end so that it can rotate vertical plane. Okay, the free end of vertical about what is released. Okay, when it is released, again conservation of energy releases related question, students. Initially this rod having potential energy, when it is released that potential energy only converted into kinetic energy, rotational kinetic energy. Okay, yes. So what is potential energy of rod means uniform rod, vertical rod of height is L is nothing but, length is L is nothing but up to center of mass only. Potential energy mg L by 2 potential energy equal to rotational kinetic energy half I omega square. So it is rotating about which axis? About this axis, one end only. One end is nothing but ml square by 3 into omega square. So here m is cancel, this 2 also cancel, here 1l is cancel. So 3g by L, 3g by L equal to omega square, students. Omega equal to under root of 3g by L. So potential energy under root of omega equal to angular velocity under root of 3g by L, given first option. Okay, students. So mg L by 2 equal to half rod one end ml square by 3, half I omega square. Clear, students? So option 1 is correct. Next, a rigid body rotates about fixed axis with angular speed 6 minus 3t, where t is time. The angle through which rotates before comes to rest. Important, students. Angular velocity omega equal to 6 minus 3t. Angular velocity becomes 0 after what time? After 2 seconds. From here t equal to 2 seconds. Okay. In these 2 seconds, how much angle subtended by the particle? What is angle theta? Very important. Integration, students. Omega equal to d theta by dt. So theta equal to integration omega into dt. Omega limits from 0 to 2 seconds. So theta equal to, yes, integration omega is 6 minus 3t into dt, limits from 0 to 2. Direct only, students. Now 6 into t is nothing but integration dt is t only, limits from 0 to 2, minus 3 into t square by 2, limits from 0 to 2. So after simplification here, 6 into 2 12 minus 3 into 2 6. So 12 minus 6 is nothing but 6 radians, students. So option 2, second option given, 6 radians. Next, consider the following statement. Statement 1. Net force on rigid body is 0 must be at rest. Not only rest, students, uniform motion also must be 0. Now here, net force on rigid body is 0, it must be rest means must is not correct, students. Maybe uniform motion also 0 only. Okay, this wrong. Must is wrong. Similarly, same. Constant speed means acceleration is 0. Again, constant speed is nothing but acceleration is 0. Constant speed at rest also acceleration 0. So that means this statement also wrong, students. So both statements A and B here in this case is incorrect. Constant speed means acceleration is 0. Not only constant speed, rest position also acceleration 0. Yes. Next question, students. 3 uniform solid spheres, each of mass is capital M and radius is capital R, are placed along y-axis as shown in diagram. The moment of inertia of system about x-axis. Very important. So here, uniform solid spheres. Let us consider for understanding first sphere, second sphere, third sphere. First sphere along the diameter passing through center of mass only. What is moment of inertia of first sphere is direct formula, students. 2 by 5 mr square. You know very well. Solid sphere. Hollow sphere means 2 by 3 mr square. Disk along the diameter is mr square by 4. Formulas very important. Moment of inertia. Okay. Now moment of inertia of second sphere, third sphere identical only. About second sphere I am explaining. Listen, students. Moment of inertia of second sphere I2 equal to, first passing through center of mass 2 by 5 mr square parallel axis theorem plus m into distance between two parallel axes. Here to here r, here to here also r, 2r. 2r whole square is nothing but 4r square. So now I2 equal to 2 by 5 mr square plus 4 mr square. That means final here 5 into 4 20 22. So 22 mr square by 5 is I2. I3 also identical, students, same identical, distance is 2r only, same identical. So I3 also 22 mr square by 5. Yes. What is total moment of inertia? Means I1 plus I2 plus I3. Total moment of inertia 2 by 5 mr square, 22 plus 22 44, 44 plus 2 is nothing but 46 mr square by 5, given option 3, students. Clear? So these model questions also very important, students. Seat deciding questions, very very important. Clear? So this is about rotational motion, students. So please like video and share video. So if you really like my video, please subscribe, students. Okay, thank you, students. Thank you so much.